It's really too bad we had that fire bell, but what can you do? We have no choice. Okay. So page 91, we made it kind of halfway down. And we were talking about KEQ, which remember is the products over top of the reactants concentration, okay? And we raise each of the concentrations to the power of their coefficient from the reaction, okay? Page 91. So, because we're dealing with concentrations, we're only going to be looking at substances that vary in concentration. So, gases can vary in concentration because we can change the pressure of a gas and that will change its concentration. So, gases, yes. Do aqueous ions and aqueous gases have a concentration? The answer is yes. So aqueous, yes. Do solids have a meaningful concentration? No. So solids, no. So when we're writing that equilibrium expression, do not write solids in there, okay? Now, pure liquids. Do liquids have a meaningful concentration? No. No. I'm going to put one liquid. No. Now, this is like, actually, I'm going to get rid of the one. This is like 99.99% of the time. Okay, so if you just want to say liquids no, never, you can say liquids no, never, and it will be correct 99.99% of the time. Every once in a while, if you have a mixture of liquids, they can dilute each other, so they can change each other's concentration. So let's say that we had A, which is a liquid, plus B, which is aqueous, gives C, which is a liquid. We have two liquids. It doesn't matter if they're in the reactants or the products, because remember, everything is in the same container. Reactants and products are all in the same container. So you can't, like, they will mix with each other, okay? If you have two liquids, then the answer is yes. Or more. Now, very rare. Yes. Oh, hello.
I have a chemistry question.
Okay. Okay, sorry about that. So let's, very rare. So you can almost just ignore it altogether. So gases, yes. Aqueous, yes. Solids, no. Liquids, no. Yes. No, but we're not going to worry about that because it takes place when? Never. Okay, so, and we don't have time to talk about it a lot, so we're just going to move on. Okay, because we got like 15 minutes now, and we're like way behind the other class because they did not have a fire bell yesterday. Okay, so let's take a look at this one here. When you write the KEQ expression, you should write KEQ equals. Okay, And then we're going to have something on the top and we're going to have something on the bottom. Who goes on top, products or reactants? Products. Now our product is a gas, so do we include it? Yes. And we're looking at its concentration, so what kind of brackets go around it? Square brackets, because square brackets designate concentration. So concentration of C2H6, does that need an exponent? No, because there is no coefficient at all, so we just leave that alone. Now we go to our reactants and put them in the denominator. Do we include carbon? No, it is a solid. Do we include hydrogen? Yes, it is a gas. So here we go, we have H2. All right, and we're going to raise it to the what power? Third power. So that is our KEQ expression. Next, what's the first thing we write? KEQ equals. Now, our only product is a solid, so do we include it? No. What are we going to put on the top? Just a 1. Okay, so if there is no solid, just a 1. Now, if there's no reactant, you can put a 1 in the denominator. However, you can also just leave it out because you don't have to have a denominator, right? Like, so if you had like, you know, concentration of A times concentration of B, and your reactants didn't have anything, you could put it in it. You could write it like that, or you could just write it like that. Yes? Did you guys catch that? Okay, cool. PB2 plus, yes or no? Yes. Yes, it is aqueous. PB. Tell me what you think of what I'm writing here. Maybe don't write it just yet. Okay, what is wrong with what I've written here? So I'm missing a charge, right? So I need to have a 2 plus here. And what on earth is the concentration of 2 BRs? Right? Am I walking around counting little pairs of bromide ions? That's just weird, right? You can't measure the concentration of pairs of something. So never, no coefficients in the concentration brackets ever. No coefficients in the concentration brackets ever. Yes?
So if we have to do examples of our test, do we have to write the formula of the constant equilibrium or just go straight through it? Like, do we have to write?
This is the formula.
Yeah, but like have to write concentration of products.
Oh, no, in fact, don't bother with that. It's just a waste of time. Okay, do not write KEQ equals products over, I see what you mean, yeah, reactants, unless you're like talking about them in the most general sense. If you have real chemicals you can put in there, just put the real chemicals in right away. Okay, not that I'm going to mark you wrong if you do that, but if you do that and then don't write the specific things, then you're going to lose marks. So it's better just to not do it unless you feel a great need. Okay, now bromide, we have Br, it needs a negative sign. Where does that 2 go? It goes in at the exponent place. All right, now here we have found ourselves a blue moon. In other words, this only happens once in a blue moon. And if you're not familiar with that expression, once in a blue moon means it happens very rarely, okay? I forget what a blue moon actually is, but it doesn't happen often, okay? Now we have a liquid and a liquid and a liquid. These are all polar. All right, so they will all mix with each other, but we're not going to worry about it. We're going to assume if I give you 3 liquids that they are miscible, that they will mix. Okay, we're not going to make you figure that out. So in this case, KEQ would equal concentration of CH3OCH3, which is a product, times the concentration of H2O, that's our other product. Neither of those have coefficients, so they don't need exponents, over the reactants, which is CH3OH raised to the power of 2. Okay? Is good? So part of your homework is going to be page 92, numbers 1 through 5. Okay? That's not it, though, because we are now moving on to page 93. So your homework today is going to be a little different than block 7 because they did page 92, number 1 through 5 in class while we stood out on a field. Okay? Right? Yeah. Okay. So example 1. Now we're going to actually throw some numbers in here. This is super easy. You're going to like this. Okay, you'll be like, oh, can the rest of the course be like this? And some of it is. So enjoy while we can. Here's our equation on page 93. At a certain temperature, the equilibrium concentrations were found to be as follows. And it's important that they are equilibrium concentrations because, of course, this is a KEQ, yes? So, if I want to actually calculate the KEQ, the first thing I need to do is write the KEQ expression. So, KEQ equals, make sure you write KEQ equals. I have only gases here, gas, 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 so I'm going to include everything. Okay, so the products, Cl2, don't write down yet, I want you to critique what I'm doing next. What do you think of what I have written? There's no plus. Now, I'm going to tell you that somebody in one of my 2 blocks is going to write plus on the quiz. I don't know why. I tell everybody every year, and somehow it sneaks in there. The brain just goes, right? You're writing a quiz, you get a little nervous, you're like, and somehow a plus sign sneaks in there. Try not to let it, okay? I think maybe people see a plus here and they get like it just moves down. Don't do it, okay? Just multiply them. Okay, so we have HF, and of course, it has a coefficient, so it does need to be squared. All right. Now we have on the bottom, we have HCl. Don't write down what I write down. You're going to critique it. HCl squared times F2. There we go. What do you think? I need square brackets. Why? Because it is the concentration, so I need to actually say concentration of HCl, concentration of F2. Excellent. And then the second thing you're going to do is you're just going to plug in the values. Plug in the concentrations. Now, here's a surprise. This is the only place in chemistry where you do not need to use units. And that is because KEQ does not have a consistent unit. It just depends on whether there's molars in there. So we just don't use a unit for KEQ. So we do not need to use a unit in its calculation. Okay, no units needed. How's that for a treat? Whoa. So we're going to put in our numbers, but no concentrations. So here is Cl2. It is 2.0 molar. So I'm going to put 2.0. You critique this. And then we have HF. Don't write this down yet. Critique it first. Whoops. I shouldn't be writing HF. I should be writing as concentration. 0.60 squared. What do you guys think? The brackets should not be square. They should be round. Why? Because in chemistry, square brackets designate concentration. And are we saying, what is the concentration of the number 2? Right? Like that's what it implies. So in chemistry, I know it won't matter if you're doing math, but in chemistry, you should be using round brackets to indicate that you know that 2 is not something you can find a concentration of, okay? HCl, we just go find its value. Here it is, 0.50. And we need to square that. And F2 is 0.40. Plug that into your calculator and see if you get the same number as I do. Did you also get 7.2? Okay, good stuff. Now let's just go through this little bit here. You are going to watch. Could someone close the door? Because we got noisy people out in the hallway. Thank you so much. Thank you, thank you. So it is acceptable to leave out the units for KEQ and in its calculation because units for KEQ don't really mean anything. Now, here's how you either lose marks or not lose marks when you're doing KEQ math. You must write KEQ equals. You must write the KEQ expression, not just products over reactants, yes? Like I said, if you want to include that, you can, but you don't have to. But you must include it with this, use the specific species. Use the chemical species. All right. You must use square brackets around the chemical formulas. Okay. If we had any time, I'd go out and yell at them, but I don't have time. And you need to use round brackets around the numbers. So NH3, yes. NH3, round bracket, no. 0.30 in round brackets, yes. 0.30 in square brackets, no. And just a reminder, don't add. Okay? No to the adding. All right, I'm going to pop up the video for examples 2 and 3 for you. So look for the one that says block 8. Block 7 is just watching example 3. All right?
I have a question.
Yes.
If there is only one side with liquid, like one side with one liquid,
Uh-huh.
is that true?
So these three are all in the same container, so you will include all of them because they can dilute one another. Yeah?